Right, so integration of trig function. So if f of x was sine of x, f dash of x is what? What we've just done. So when we differentiate sine, we have cos. Okay? F of x is cos of x. F dash of x is what? Negative sign. And if f of x is tan of x, f dash of x is what? X squared. Okay, so we're going back the other way now. Okay, so the integral of cos of x with respect to x. Okay, so when we differentiate sine, we have cos. When we integrate cos, we go back to sine. And integration.
Do we get this stuff on the sheet?
Yeah, I got verified from our deputy that you will have that new sheet with all your assessments now, which should include that from memory. Okay, so this will be on your formula sheet. Okay, but don't rely on your formula sheet. We'll talk more about that in next couple of lessons. But the integral of sine of x with respect to x. Right. So when we differentiate cos, we get negative sine. So when we integrate sine, we're going to get what? With the negative, okay? So negative cos of x plus c. Okay, that's how I remember it. I differentiate first and then I integrate. Right, so you differentiate sine, you get cos. That will help you with your sine. Right. The third, the integral of sec squared in there. The integral of sec squared in there. Okay, so when we differentiate tan, we get sec squared. So when we integrate sec squared, we can get back to tan. Right, so that's our basic one. Right, and then generally speaking, so the most you'll get inside that bracket will be a linear function. You won't be asked to do anything higher than linear in here, as far as I am aware. Okay, so this is going to be 1 on A sine AX plus B. That's our constant expression. Right, so we divide by the derivative inside the bracket, just like when we integrate using our function of the bunch rule. Right, so to finish that off, we need to divide by the coefficient of x. Right, so the integral of sine AX plus B dx, 1 on A again, so we divide by the derivative, and then we have negative sign, of course. And don't forget your constant integration. Okay, so the same as over here, just dividing by the derivative inside the function itself. Right, so we differentiate tan, we get sec squared. When we integrate, back the other way, we integrate sec squared, getting back to tan. When we have a linear function inside the bracket, which works here as well, because you're really just dividing by 1. Right? There's your general formula, it's just backwards. Right? And that general formula, as far as I am aware, they are on your reference sheet, which is called now, reference sheet. And let's look at that either tomorrow or down the track. Right, so there's your rules that you need to know. So lead today, we need to be able to differentiate sine, cos and tan, and then we need to be able to integrate cos, sine and sec squared. Alright, so if you remember, you differentiate sine, you get cos, that will help you with all your sines. Alright? Alright, example A, find the integral of cos 4x. Right, so you've got to be careful because the coefficient is not 1, they're going to treat using the general rule. Okay, so when I differentiate sine, I get cos. When I integrate cos, I'm going to get sine. So 1 over the derivative . When you differentiate sine, you get cos. When you integrate cos, you get sine. Alright, which makes sense because if you differentiate sine here, this is going to be 4 times a quarter of cos of 4x, which is that. Alright, that's essentially the proof there for you. So, more applications involving integration. Okay, so let's evaluate pi over 4 to 0 of sec squared of 2x. Right, so we've got indefinite integral, means we do not know the bounds of integration here and here. Alright, so that's why we need to include the constant integration. And until you're told further information about it, okay, we have to treat it as if it is a general constant. Right, this one's a definite because we know the end point of integration, so we were finding the area as, for example, right, we know where we're bounded. Right, so we differentiate tan, we get sec squared. Alright, so we integrate sec squared, we get tan, however, we've got that coefficient we also need to deal with. So it can be tan, 1 over 2, sorry, tan of 2x. Right, so 1 over the derivative of what's inside with the sec squared, find tan of the same function, and then we have the end point of integration. Right, so the half, I'm taking the half out of both those terms, we've got tan of pi on 2. Careful with my questions there, because what is tan of pi 2?
Asymptotic.
That's
Undefined.
It's undefined. Alright, so I'll probably look at the question and realise I have 2 as part of it. Alright, so let's change. Let's change that. Right, let's change this to a pi on 8 so that we can at least have an answer. 4. Right, so what is tan of 45 degrees?
1.
1. The half. 1. Take away what's tan of 0?
0.
0. Right. You're not asked to find the area, right? So we're just having a constant value when you integrate and substitute in. Okay, no need to write units because you are not asked to find the area. Right, so now we've got an area question. Find the area under the curve. Y is 2 cos of 3 of x between x is 0, x is pi on 6, about the x-axis. Okay, so about the x-axis, we need the opposite letter of the subject of our equation. Or we need to integrate everything that has x's in it. So area is the integral from pi over 6 to 0. Now, constant numbers can be moved straight out the front. You don't need to include it into your integration, because I'm going to have to factorise it out anyway. Right, so I've already got my y equals for my bounded by the x-axis. Right, so we're in 2. Okay, so we've got integrate cos. Remember, when we differentiate sine, we get cos. So we integrate cos, go back the other way, we're going to get sine.
Is it a negative? Negatives.
Differentiate sine,
Oh, okay.
you get cos.
So,
Integrate cos, you get
I
sine.
expected to remember this.
Well, you just learned it today, so I'll forgive you. Right. You try and make up your own rules in the future, I won't be so forgiving. Alright, so did everyone follow how I got from this step to this step?
Yeah.
Yep. Alright, so I'm just taking a couple of shortcuts so I don't have to show every tedious step. Alright, so equals 2 over 3. Sine of 3 pi on 6. So it'll be sine of pi on 2. And observe got 0, so observe got sine of 0 to 0. Alright, so you don't need to show the substitution when it's trivial, the answer goes 0. Alright, what's the sine of 90?
0? Oh.
You got your sine curve.
1.
One.
Negative 1. 1.
Maybe I'm not rubbing
Which one?
1.
Which one? Which
It's a
one?
negative. No, it's not.
No, it's 90. 1.
What's your
Oh,
sine
90.
curve? Right.
Why am I thinking of 270?
This feels really good.
Who's going?
No, the pen was open. I don't clean my ears when I get home because it feels really good.
Alright, 2/3. So the exact area for the curve to cos 3x, we've got an amplitude of 2, we've got a period of 2 pi and 3, and the exact area is 2/3. Unit squared. It's amazing how things work out.
Wait, how are we supposed to know that one's so close to have a unit?
Hey,
Or how
It's
the
do we-
question did say find the area.
Oh.
I just didn't write the whole question. Kyle should listen more in class.
Oh, come on, man. Let's go. What is that?
Alright, so what's the other thing I'll do with integration? So, indefinite integral, definite integral, area.
About the x and y axis.
What's the other general thing I do? No one, no.
Is it
Definite
forming-
integral, hey? Yeah, which is what?
Forming volumes around
Volume.
the x and y axis.
Ah, let's find the volume of the revolution, find the volume of revolution formed when the curve y is the square root of sine x is rotated about the x-axis between x is 0 and x is pi on 6.
Yeah, maybe. Actually, wait, let me say what
I would make a mandarin looking thing.
Hey,
It looks like a mandarin.
Mandarin.
Yeah. That. It's like a semicircle. It looks like a mandarin. Really weird looking mandarin.
I thought it was weird enough what you said.
I fell in my significance.
Alright, so to find the volume, what do I need to do?
integrate it and times it by pi.
Yep. Integrate what?
Everything.
Okay.
Everything.
Everything.
I can't.
let's put it this way. Do you guys know how to integrate square root of sine of x?
Yes.
No.
Do we? Would it be
No,
sine
no,
x,
no, no.
sine x to the power of 3 over, no, not 3 over 2, 1
Half.
over, 1 over.
So sine 3
I got it.
sine x cubed square root. No, not square root.
Okay.
I can't remember.
So what's the formula for volume?
Is it pi the integral of
A.
A. What's the formula?
f of x?
Is there an A in it? A and B?
Just put it there.
Yeah, wait, I saw it.
F of b take away a. Damn it!
Is it half b take away
X. BA x squared dy.
What?
No, around the x-axis. So
Y
y
squared dx.
Y squared dx.
Oh
The
yeah, we did this, didn't we?
Geez, you're only going to be assessed on this about 2.5 weeks.
It's okay.
Do we only have 2.5
We all
weeks
fail
left?
together, it's alright.
Walk on. Yeah, it's gotta be easy, gotta be easier. Rather
Which
easy.
work have you done?
Just trying to remember.
Based
all
on that
load.
response today, some people really need to go over their work. Ready?
We've got 2 days.
Your assessments are on your official notification tomorrow, but your assessment will be on quadratic function,
Mhm.
integration, and now today, well, the last question on this topic, so we'll be on trig function as well.
Oi, oi.
Okay? 10%. Ah, pi, the integral from pi over 6 to 0, so it's about x-axis, sorry, so I need y squared the subject, so if y equals square root of sine of x, y squared is what?
Wait,
Sine
start again.
If y equals the square root of sine of x, and I need y squared, so I can substitute that in there, y squared is what?
Sine of x. I know that one. I get that.
No,
Right.
fail.
You square both sides, get rid of your square root.
It's a mark.
Okay? So now the integration is easy peasy. Alright, I'm going to say this one more time today.
Yes.
When you differentiate sine, you get cos. So when you integrate cos, you get
Sine.
sine. So you're integrating sine. So this is one where you need to change the sign. Okay, it's going to be pi, negative pi, cos of x. And because we are finding volume, so we need a positive quantity, alright, this is where we need to take the absolute value. Alright, we need a positive.
No.
Alright, so negative pi, so you can't just say this is pi, okay, because if you do say this is pi, you'll be wrong. Alright, because you've got cos of pi on 6, take away cos 0. Now, no, I didn't, that's just write 0 there.
Because cos of 0 is
It's
1.
greater than cos of pi on 6. So therefore, what's inside that bracket is going to be negative. Okay, so if you say pi outside of cos of pi on 6 take away cos of 0, you're going to be wrong. Okay, because you got what's inside the bracket, it's a negative already. So, negative pi, so we're going to take that for value. Cos of 30 is what?
Cos of 30 was
Root 3 or 2.
Okay, so root 3 over 2 is less than 1. Okay, so you can't just remove that sign. Okay, so equals pi, also need to swap these two values around. Okay, everyone work out what I've done. Okay, because that's bigger than that, so if I swap it around and take the minus out of here, so I've undone what I've done, that will be my volume of revolution. Unit to cubes. Alright, that finishes trig. So that's now all your exercises and your test yourself challenge exercise at the end of the chapter. Everything up to and including today this term is accessible in your assessment on Thursday fortnight.
Cool. So now do we have working lessons?
Tomorrow will be working lessons. Thursday we start logs and exponentials. Okay? So that we can finish logs and exponential at the end of the school term. So that way we can start fresh on a new topic, which would be geometrical abstract calculus.
Build instead.
Curve sketching.